Alright then. So before we start with the interfacing, there are basics which are related with the concepts of handshaking, and there are few signals involved in the handshaking. So we'll call those signals as handshaking signals. Right. So before we start about the handshaking in the interfacing or wherever we are having a data transfer between two devices, two layers, two networks, you will always find handshaking signals traveling within those circuits. So why do we actually need them? The question is, why do we actually need handshaking signals, or what is the phenomena behind the handshaking? Fine. So when we talk about connecting two hardwares, connecting two devices, connecting two layers, or just a client and server kind of thing, so it's not always like they both are running at the same speed. Fine. So if I connect, let's for example, I connect a microprocessor or computer, and the peripheral you are connecting here is printer. Right. Now processors speeds are defined in term in a unit which is in per second. Like there is one term called MIPS. MIPS stands for million instructions per second. So processors can actually execute a million instructions in a second. Fine. On the other side, I'm having a peripheral. Let this peripheral be a printer. And what the maximum speed you know about the printer? How much pages they can print? Generally, they are given in ppm, pages per minute. Let's say just let's have a random guess. How many pages maximum? How much you heard about?
So
The
10 to 15.
10 to 15 pages per minute. No, it's not. It's a lot more than that. The fastest I heard about a printer, it was like 300 pages per minute. It can actually print 300 pages per minute. Fine. But still, try to understand the phenomena here. So what's going to happen? The moment you know that you have a computer and you are writing a document and you want that document to be printed, what you press? Control plus P. Then you have a print dialog. In this print dialog, you select few options. Then you press enter, and then enter loads that command inside the print buffer, and then from the print buffer via the spool, that will be loaded inside the memory or the buffer of the printer from this side to this side. But look at the speed. There are differences in the speed. This is working in per minute, and that speed is very low, and this is working in per second phenomena, and within 1 second it can load a million number of instructions. Let's say within one instruction it is loading. Let's say my first instruction is I want to print 100 pages, first command. Fine. Within the next second I loaded one more command, that second time I want to print 1000 pages. But what problem we are having? The problem we are having is this printer might be already working or already printing the previous command. Fine. Once it is finishing or it's finishes that previous job, then it will take the next one. Then it will take 100 pages. It will take its own time. Again it will be loaded with 1000. So just imagine the speed difference we are having here. The processor is working like this. Fine. And this peripheral is working like this. Fine. So are we actually going to work in that environment where somebody is working on one end, somebody is working very fast, and somebody is walking very slow? Can they coordinate? Can they really coordinate? Tell me, someone who is very fast, like Usain Bolt, and someone like me, I can't run that fast. I can never outrun Usain Bolt. So will there be any coordination? No, he will always win.
He'll always win.
He'll always win. The processor will always have the upper hand in doing these things. Fine. And this is a printer is a hardware which is actually having so many solid state devices inside, motors, belts, small driver circuits. When it is continuously getting loaded with a number of commands and it is working tirelessly, 1,000 pages, then 1,000 pages, then 1,000 pages, will they remain same in their operation? There are losses associated with the solid state devices or the rotary devices. With the sensors, they have a life cycle. They do not remain same always, like they were manufactured in a factory or wherever they were manufactured. They have a life, they have a wear and tear problem. Even your toner ink will finish. Fine. So there are issues with the peripherals. They may not be able to comply with this processor. The processor is sending very fast, but printer is not able to comply and it is loading it again and again. So what possibilities we can have in the hardware? The hardware can behave in an unpredicted manner. Their motors can stop working, the toner refill that may be leaking, the belts may start making noise. There are many issues. At some point of time, they may feel like, yeah, now this thing is very hot, no, nothing is working. You just switch off the device so that they may cool down. It do happens in the practical environment. It do happen. Fine. So what do we want? Do we want that system to remain like this? Or we can do something so that something can have a coordination or something can set up the coordination in between them. Fine. So let's take another example. This was the example when it was for output device. The printer is an output device. So let's take the case of input as well. So input, I take it again. This is my processor, or let's say it's a computing system. And this time we are having an input peripheral. The input peripheral, let's say keyboard, the best. Fine. So once we are having a keyboard, I'm providing a command from the keyboard to the processor. What processor can do? It can actually work for million instructions per second. But what is the human limitation? What is the fastest? How much words can we type in a minute? It is again in a minute form. Words per minute. So what do you guess? How many words can the fastest human being can type in a minute? How many? Anyone?
20 to 25?
In a minute?
Yes, sir. Or the fastest one?
It's more, way more than that.
500.
500, maybe 500. Have you heard somewhere? 500?
No, sir. Guess.
Okay, just guessed. Anyone else?
Sir, around 200.
Around 200. Yes, the highest typing speed ever recorded was 216 words per minute by Stella Pahunas in 1946 using an IBM electric typewriter. That typewriter was electric, not that analog type tuck tuck. Fine, so you can see 216 was the highest biggest number we are having in the speed of keyboard. So what are we looking here? The processor is running very fast. It can work very fast. But the way we are loading the command, it is very slow. Fine, the processor can take it way faster, but we have a human limitation that it needs that the speed by which it can take. We can't provide the data, or we can type the code instruction. All right. So are you trying to visualize that what we are having here? We are having here the differences in the speed and both ends, on the left end or right end, or you can also say the processing end or the peripheral end. Fine. So whenever we are having differences in the execution speed or the processing speeds, the only word which comes in your mind as a rescue, this is your rescue. Always keep in mind, this is the word of rescue. Handshake. Fine. So it comes from this human real life. So whenever two new people meet, the first signal they transmit is they handshake. Generally, in the COVID times now we are not doing the handshake, but in a general greeting procedure, the handshake is the phenomena to meet. Fine. So they took it from that place only. Whenever two hardware or devices they are going to interact, they're going to communicate. The first signal that they will be transferring will be the handshake. Fine. So handshake signals will play a very big role in um, what should I say? In settling these variation in the speeds, or if I give you a single word, what they will provide you? They will provide you sync or synchronization between the speeds of the processing or the processor side and the peripheral side. They will provide the sync, because at the varying speed, they will not be having synchronization. Processor will keep loading, and the printer will not accept it. But at some point of time, the memory buffer of printer will full, but processor is not having any idea about the memory buffer being full, so it will keep loading. So there will be a loss of signals. Likewise, in the keyboard, here the phenomena is different. The processor can take too much, but we are not able to supply. So these are the problems with synchronization. So there are few signals which will run in between, and those signals will be called handshake signals. Fine. And there will be two configurations. We'll be having two configurations definitely that we have studied: data input with handshake and data output with handshake. So let's start with the first one, data input with handshake. I write handshake like H/S this. Fine. So once we know about the data input handshake, let's understand the structure. This figure which has been drawn in front of you, there are three blocks here. The first block is your microprocessor. You can write it like 8086 or 85, whatever it is. Next block is your PPI. PPI stands for 8255. What PPI will do, it will provide ports. It will provide the ports where the peripheral can be connected. Next is your peripheral. Since we are talking about the input case, so what peripheral should be? There should be a input peripheral. Let's say keyboard. The keyboard I'm taking as my input peripheral. Fine. What next we have in this figure is there is a common data bus traveling or connected to all of these. This is a common data bus, you can see. It will be connected to all of them. So let's start with this and we'll go step by step. So tell me from where the communication will start in the data input, from where the very first communication will start, either from left side or the right side, from where the communication will start, the process will start. Think logically. From left side or right side? From processor side or peripheral side? Anyone? Okay, you guys still not able to construe, I guess. So let me explain a little more. So process, everything will start from the peripheral in the input side, because until and unless you are not going to press a key, what will be processed by the processor? Even if you're typing a document, you are creating a document will remain as it is, even if you, until and unless you do not put or you do not type or you not press any key. Fine. So the input, data input with handshake, in this mode, everything will start from the peripheral. Fine. So that key will be pressed. The peripheral is connected to 8255. There will be a mediocre communication. Fine. So how these things start? So always, whenever we create a communication, uh, are you guys still with me? Am I clearly audible?
Yes, sir.
Yes, sir.
All right. All right.
Yes,
So better, because what I'm going to tell you right now is very complicated. This is what I'm not supposed to tell you. See, whenever we are transmitting a data always has its length. Let's say 8 bit. Fine. So when you transmit a data, let's create a data 0110 in the binary 1101. So what happens is how this travels in the form of waveform. So this is 0, 0 means low, 1 means up, 1 means up, 0, 0, up, 0, low, and this is now. So this is how your this binary pattern will look like this. Okay, but the moment we transfer any data, fine, it is not exactly like it, because what you are seeing here is this data is raw data. This is the information. Fine, and if it is not protected by anything, if it is not having any kind of protection attached to these bits, it can be easily hacked. Anybody can see which data it is. Anybody can access your information. That's why these days you are having so much allow options. Everywhere you download something new and you transfer or use it. Until and unless you allow it, nobody can access. There are layers. So that the moment you create, you click on that allow button in your mobile or in your laptop, you are just removing some layers so that they can access the information. Fine. So what we need to do is, this is my data. This is the information I want to protect. Fine. So what happens is, the moment we transfer this data, fine. Along with this, there are so many bits which travels. Fine. So there is a bit which is called start bit, and there is one more which is called stop bit. So along with this 0110 along with this, there will be a start bit and stop bit. Start bit, the job is to inform the next bit is the information bit, so that processor will start counting. Stop bit is, it informs the receiver that you should stop, do not move further, this is the end of the data. Fine. Next, for error detection and correction, we have parity bits. Fine. Along with these, if you want to add some security layers, like in Windows, what do we call that WSN key? Windows Security Network, something like WSN1 and WSN2. The passwords you create in your Wi-Fi, we call something like Windows Security Network, like WSN1, WSN2. If you want that key to be established, that should also be there. Security. Then frame setting. How much frame do you want to transmit? 60 fps, 100 fps, or 120? So just imagine, where is my information? This is my information. Fine. And along with this 8-bit, how many extra bits are traveling? Let's say 4 here and 4 here. 4 plus 8, that means the total transmission is of 16-bit. But along with 16-bit, the information, the critical information, which is actually the message is only of 8-bit. All other things are getting extra, and I haven't told you, along with this there will also be a handshake bit which will be helping with the various levels. Fine. So what happens, just try to understand why we are so much concerned about this bandwidth. Why we are so much concerned about the bandwidth in terms of network. 100 Mbps, small b, capital B का ध्यान रखना हमेशा. 100 Mbps, now we need 300 Mbps. Now Geo Fiber is giving you 300 Mbps. Why do we need bigger bandwidth? Why do we need bigger bandwidth? Because along with that bigger information, now we have 4K videos running on the YouTube. Fine. So just imagine that bit pattern of 4K panel, how many bits it will be, and along with that bits, how many more bits will be added. So information is getting expanded, the number of bits are expanding in the information. Along with information, we do transmit so many other information. So just imagine how we are looking for the bandwidth. Why do we need a bigger bandwidth? This is why we need bandwidth. This is because along with the information, the actual signal, there are so many other bits we need to transfer. All right, understood? This is a deep core concept of digital communication. Is that understood? Is that clear, everyone?
Yes, sir.
Yes, sir.
Yes, stay tuned with me, because these are very complicated concepts. I need a little feedback. So let's start with the peripheral. So what happens is, the moment you press a key, let's say you press capital A or small a, it could be anything, A will not be traveling. Along with the A, there will be something which will be informing the processor or the PPI first. There will be a signal. Let me change this. Fine. Yes, and that first signal is called STB. STB stands for, this is not start bit, STB stands for strobe. Fine. So once you press any key on the keyboard, before that key there will be a signal which is called strobe. Strobe will do what it will be doing. The strobe will inform the 8255 that next bit will be the data. Fine. So after strobe, the bit you just pressed or you just typed, that bit will be loaded into the data bus, and whatever the bit pattern you have, the sky value will be loaded, and from the data bus it will be loaded inside the input buffer of 8255. It will be loaded into the input buffer of 8255. Okay, now what? Now this key which you pressed is in input buffer of 8255. Now what will be the next job? The next job is 8255, which is a PPI, will inform the printer, the peripheral, your keyboard. What is the next signal? Next signal is IBF. IBF stands for input buffer full. 8255 is trying to say to the keyboard, do not send the next bit or do not send the next byte. My input buffer capacity is full. It is having only 8-bit buffer. 8-bit you have already copied. So next आएगा कहाँ जाएगा? It will be loss of data. So 8255 is informing back to the peripheral, do not send the next byte. My input buffer is full. Second job. Now what will be the third thing? Now that peripheral key is in 8255. Now 8255 will inform your microprocessor 8086 or 85, whatever it is, by sending an interrupt signal, INTR, interrupt request. What interrupt request it is? That something is going to be read. I have a data for you. Please accept, acknowledge, whatever it is. Fine. So 8255 will send a signal to the processor, and that signal is INTR, interrupt request signal. Fine. Now wait for the processor. Wait for the processor, because the priority calculation is still, I'm not giving you the priority calculation right now. So let's wait for the processor. Okay, the processor is free now. Now processor receives the interrupt, it settles with the priority. So what next processor will do? The processor will send a control signal which is called read signal. Fine. Processor will say, okay, let's read what is coming in my way. So from this input buffer of this 8255, that value will be loaded into the data bus of 8086, and from data bus it will be settling inside somewhere, which is your accumulator, and that value will be close to the microprocessor. Now processor can read it wherever it is designed. The value has reached. My whole concept is to demonstrate how this value will be traveling. Fine. Once the value reached at this spot, your STB and IF, they will be released, they will be removed. Fine. RD removed already, INTR, all these signals will be removed. Fine. And the cycle will be re-established. Fine. So let's understand it again. First step, strobe signal from the peripheral. That means the next byte is your data. After strobe, okay, let me put some step by step. Okay, the first one is your strobe. After strobe, the byte will be loading into the data bus. Then it will be stored into the input buffer. Third step. Fourth step, IBF will be sent to the keyboard peripheral. Fifth step, interrupt signal. Sixth step, read command by the processor. And seventh, finally, value getting loaded into the data bus, and finally inside the processor where it is destined to. Is that clear?
Yes, sir.
Is that thing clear?
Yes, sir.
Now do one thing, just quickly in your mind and look into this picture, remove IBF. Just imagine there is no IBF in this picture right now. Let me erase it. Just think of a second, there is no IBF in this picture. Like this. Now what will happen to this? What may happen or what can happen? Just think, there is no IBF. Now just think about the process. What's going to happen? What will happen to the input buffer of the 8255? What will happen to the input buffer of 8255, since it is not sending any signal back to peripheral that stop, do not send the next byte, and it is sending the bytes again and again. You're typing and again it is getting loaded. So what it will be having, it may be having overflow. It may be having overflow, and that may also have a condition. I'm just giving you a picture. Suppose you just loaded some value 0110, 1101. That the time it is getting loaded into the data bus, the half has been loaded, and immediately the new value has been pasted. So you may feel like there is a mismatch of data. Some bits are from other data, some are from other. So that there are various things that can happen if you remove any of the handshake signals. If you remove strobe, they will not be informed exactly what the next signal is. So are you getting my point? Are you understanding it now, the importance of these two signals, STB and IBF? So STB and IBF are the handshake signals in the data input. These are the handshake signals which are actually giving you what? They are giving you synchronization between these two devices, the processor and the input peripheral, which is your keyboard. Otherwise, there may be many bad things happening in the circuit. Is that clear? All of you?
Yes, sir.
All right. If it is clear, let's move to the next one. The next one is, since we have already done the data input, and now we'll do data output. Now things will be a little different. Not different, but a little more. So data output with handshake. Fine. So in this case, again, I'm having three blocks. So let's create them. All of you, please note them somewhere, just like I'm doing it, just for your reference, for a quick understanding. So here I'm having the processor. In the middle, I'm having the 8255 PPI, and this side I'm having the peripheral. So I'm having the output case this time. So peripheral, let's say I take it again, the printer. The output peripheral we are having here is the printer. Fine. So same question I'm asking again. In this case, from where the communication will start? Think logically and give me the answer. From where the communication will start? Quick.
Microprocessor.
How?
Left side.
How? Yeah, you are right with the answer. I just need to know how.
It will give the output ना input आ चुका है तो output ही जाएगा बाहर.
That will give output, but what will be the command that will be traveling from microprocessor? What instruction? Definitely it will start from here, but what instruction that will be? Okay, let me tell you. The moment you click on that print dialog or print dialog box you create, in control P print dialog, there are many options like which page you want to select, how many copies, quality of printing, size of the paper, letter, portrait, and then finally you click on the OK button. The moment you click on the OK, the options we were selecting during the drop down and the radio buttons and button boxes, what were we doing? We are creating a set of command. All right. So that command was getting set inside the print dialog. Fine. So what we are doing, the moment we create a command, that means we are writing a command inside the print. Fine. So the signal that will be generated from the microprocessor is the write signal, WR bar. The processor will write the command in the output buffer of 8255. So this is what I want to transfer to the printer. This is my output command. So whenever we provide the output command, that will be written by the processor in something. Okay, so the command that will be generated first is your WR write command. Processor will write to 8255's output buffer. Fine. Now, if I correlate with the previous one, now tell me what will happen next. Correlate with the previous one, because everything will go in the sequence. You already know the process. Now try to just apply the previous process in this one. Quick. What will be the next signal? From where and to where? Or how do you want it?
Output buffer will send the signal to the microprocessor.
Output buffer is in 8255. You can simply say PPI can send a signal back to microprocessor. Alright, this is what you want to say?
Yes.
Alright, anyone else?
Sir, output transfer to data bus.
Output. Okay, that will be a later process. Just try to correlate the steps. The steps will be same. ऊपर जो steps लिए ना, they will go same in parallel. I just want you to relate it with this output phenomena. Like she just said, PPI can send a signal back to the processor. That can also be a part. I want to explore more. Is there any other way? Okay, how many of you agree with that signal? That PPI should send a signal back to the processor to inform. How many of you agree on this part? That this will be the signal? I'm just having a poll. You can just say yes or no in your microphone.
Yes, sir.
Only one yes. That means
Yes,
majority
sir.
is 2. What about others? Or should I create 3 yeses? So let me draw one more with a different color. Let's use. So I'm using 2 arrows. One is of green color and one is of that, I don't know, it is violet or purple. Let's say violet. Fine. So how many of you go with the green? How many of you with the purple or violet? Which one is correct? Green or violet? Quick. Just give me the color. Green or violet?
Violet.
Okay, how? This is the new answer. I want a little more. Why you are saying violet? Any specific thought behind?
So process is going through in that direction, and that's why.
No. It's not like that. We are
We
talking
have
about
the
signal
devices
side.
right outside. We have to show the output. So it will go like that from microprocessors to PPI, then on the peripheral devices.
No, it's not about flow. It's not about flow. The answer is very complicated because you need to understand something from the. I say that right now we are designers. We are creating the hardware. We have to think like a designer. And designer has a very good and broad framework of thinking. Fine. So right now the thought process, just try to understand the thought process. What microprocessor is this is acting like a master right now, and they both are acting like the slaves. Fine. Or you can also say it like this is me, your felicitator or teacher, whatever you say, and these are you students in my class, and there is a scenario like, okay, today you will be informing me, sir, आज तो ये पढ़ेंगे, आज वो नहीं पढ़ेंगे जो आप प्रिपेयर करके आए हो, but today we'll study something else. Do things work in that way, or do things work in that way?
No,
I do
sir.
not want to use the word slave. Fine, there is a reason behind. Or if I use a slave can never give command to the master. Just try to understand the phenomena. The master or the processor knows everything. He's the god of communication, god of processing. He knows everything. when to transmit, when not to transmit. Fine. So you can never give a command from the slave side to the master side. That will not be accepted anywhere in the world, even in the machines. All right. So that signal from PPI to uh, processor will not be accepted, because PPI can never stop that. Stop, do not send the next byte. My buffer is full. It will not go like this. Fine. So let's start from the beginning. So processor, the first thing is the processor will write the command, and the command will come through this data bus, and it will be loaded inside the output buffer. Fine. Now the output buffer of this 8255 is loaded. That means it will inform your peripheral that my output buffer is full. There is something for you to print. There is something for you to print. The signal will be OBF. OBF. OBF stands for output buffer full. It is informing the peripheral that my output buffer is full. Get ready to print. Fine. Now it depends on the peripheral now. It depends on the peripheral now. That peripheral is already doing something, or it happens, it is off. Depends. That we have to wait for the response from the peripheral. So once the peripheral is free, the peripheral will respond back by sending a signal which is called ACK. ACK stands for acknowledge, or acknowledgement. You can say acknowledgement. That signal will come from the peripheral side. Fine. So after receiving the acknowledgement, the data from this output buffer of 8255 will be loaded into the data bus. Fine. And it will be loaded into the buffer of this printer. So whatever command we have will be loaded into the printer. Now what next? The command which was initiated by processor traveled all the way, and it gets loaded into the printer via handshake signals. Now what it has to be done, the next is the PPI will send a signal back to the microprocessor via interrupt. Via interrupt. It is not giving the controlling, it is a request. Interrupt request. Fine. That now you can load the next byte. What is the meaning of that? Interrupt signal is the first byte has been loaded and executed. Now you can load the next one. So what will happen next? Again the process will restart. So let's understand that with the sequence. The first write command will be generated. Now for write, something from inside will be loading into the data bus, and data from data bus it will be loaded into the output buffer. Fine. From output buffer the signal will be generated, that is next, that is OBF, output buffer full, to the peripheral. Peripheral will respond back. After response, the output buffer content will be loaded into the data bus to memory buffer of peripheral. After that 8255 will respond back to the microprocessor by sending INTR request, so that the cycle could be reinitiated. Is that clear? Is that clear?
Thoda bahut, sir.
Yes, sir.
Thoda bahut. Where is the doubt? Because this is the time to ask. Although it's been recorded, this is the time to ask. You can clear your doubt. Tell me.
So from the fourth step.
From
Fourth step.
fourth step, OBF.
Yes, sir.
All right, let's understand it. And it again, processor will send a write command. This is what needs to be printed. That command will be coming from the data bus to the output buffer of 8255. Okay, till that point it is fine.
Yes,
Fine.
sir.
After receiving everything in the output buffer, the 8255 is sending a signal to the peripheral. कि भाई मेरे पास कमांड आ गया है, द प्रोसेसर हैज लोडेड अ कमांड टू बी प्रिंटेड. Fine. Output buffer is full. My output buffer is full. PPI is informing the peripheral that my output buffer is full. Get ready to be printed. Fine. The moment it receives the OBF, the peripheral is already doing something. It is already doing printing. So until and unless it is not sending the acknowledgement back, there is no process, there is no response. Fine. So once the printer is free, it is ready to receive the next command or next byte, it will send a signal back to PPA. Okay, I acknowledge, I accept. Next, from that output buffer, the byte will be loaded inside the memory buffer of peripheral, which is a printer containing your command which is to be printed. Fine. So after receiving this command, it will start doing the printing. Fine, the printing will finish at any time, depends on the command. So meantime, what 8255 will do? 8255 will do, it will create INTR and it will inform the microprocessor back the previous byte has been executed or it has been sent for the printing. Now you can load the next one. Fine, same process will reinitiate 1, 2, 3, 4, 7 and it keeps going on like this 1, 2, 3, 4. Is that clear now?
Yes, sir.
Better?
Yes, sir.
Okay, anyone else having any doubt? Because that would be better if you ask it right now. Anyone else? Okay, that would be better because that's why I focused primarily on understanding the concepts of interfacing first. Connecting two devices are very easy, but the signals which will be flowing inside and the concepts, these handshake concepts. So let me give you the final picture. The handshake signals that we are having in the input side are strobe and IPF, and finally on the output side is OBF and ACK. Just remember these, they are the handshaking signals which will be running in between your two devices, two hardwares and data transmission schemes. Fine, so this is also called, this whole phenomena that we discussed, this is also called one-way handshake. This is also called one-way handshake. Because in networking, there is one more concept of two-way handshake. In your networking, there is one more concept of two-way handshake. So what happens in two-way handshake? I'm actually running short of time. So two-way handshake, अभी बता दूँ तुम लोग को, because sometimes they ask you in the interview if you know about the handshake. Okay, then actually we are still needs to take the attendance also. So I'll tell you in the next class.